Hi Pre-Calc. Today we're going to do 2.1. This is quadratic functions. We're going to be graphing them. And if you remember, quadratic functions look like horseshoes when you graph them. We call that a parabola. What's a little different about this section than the previous section in chapter 1 when I had you graphing is that the quadratic function is not in vertex form. Okay, you can't see the vertex. So if you don't know what I'm if you don't know what I'm referencing, I'll write it for you. So in the previous chapter, the parabola was set up so we could see the left-right shift, the up-down shift, and whether it was face up, face down, or wide or narrow. Hold on a second here, I need a little coffee. Okay, so this parabola is not in this format, so I cannot look at it and tell where the vertex is. There's two ways I'll show you to find the vertex. The first way I'll show you is complicated, so those of you who are, you know, STEM majors, you may want to, you know, this may be something you want in your tool set. And the other one I'll just show you by a formula, which is less complicated. Either one's fine on the test. It's indifferent. You just need to make sure you get the vertex, okay? So the first way I'm going to show you how to find the vertex is called by completing the square. There's many ways to use completing the square. We use it for solving equations. We use it for formatting circles. We also use it for formatting parabolas. You're using it with one-sided balance. Okay, so this is how you're going to do it. You're going to move this into this form. So the first thing you want to do is you want to move the constant over to the side. Okay, that's the first step. You want to push the constant away from the side. The next thing you want to do is you want to force the front term to be a positive 1. Now this is the part where people get a little confused. Whatever you force off of the x squared, you have to take it off of the front two terms. Okay, not just the first one. So it doesn't, I'm using the word force because it does not matter if it's a common factor or not. You take it off. You divide it off. You take it off from both of these terms. It doesn't matter if it makes the middle term have a nasty improper fraction or whatever it does over here, just a nasty fraction. You just take it off of both. So I'm going to factor off a 2 from both. It just happens to be friendly on this one. I'm getting it to go into there evenly. Now I'm leaving a space here because I'm going to determine what the third term of this trinomial is. And I'm going to determine it so that this factors into 2 equivalent binomials. So it looks like 2 photocopies of itself. So this is the part where you complete the square. And the formula for completing the square is 1/2 b quantity squared. B is the number in front of the linear term. So it's the coefficient of the linear term. So for me it's a 4. So I'm going to plug this in. So I'm doing 1/2 times 4 squared. 1/2 of 4 is 2. 2 squared is 4. Alright, so this means that for this to factor into a perfect perfect sum, you're going to have, it's going to be 2 photocopies of the same thing. I have to have a 4 here. Now this is tricky because I didn't just add a 4. I actually added a 4 that's being multiplied by a 2. I added a 4 that's being multiplied by 2. So I actually, what I did overall is I actually added 8. Okay, I actually added 8 here. And by adding 8, I've changed the equation. And you can't do that. You can't do that. You can't change the original problem. So what I have to do is I have to take away what I put in, right? So since I added 8, I have to take away 8 so that I added nothing and I didn't do anything, right? So little magic trick here. I add 8, I subtract 8 on the outside, and now I have an added anything. It's still the original function because what I've done equates to 0. So it's still the same equation. Okay, so now we're almost there. We're going to factor this. Right, so don't write it as like x plus 2 times x plus 2. Write it as x plus 2 quantity squared. Okay, so this is a perfect square of sum. I knew it was in my brain. I was trying to find the language for it. My brain was like, nope, can't find it. This is called a perfect square of sum because it's two identical binomials, which we can write as quantity squared. All right, and then you simplify the little numbers over here. This is a minus 1. All right, let me see. All right, let me just write this over here. Now, I just moved exactly what we had, okay, gang? You know, I could finish a little bit more of it here, but I'm going to then need more space. Let me just use a little bit more of this paper. So the vertex here, remember the vertex, it's opposite of the inside, same as the outside. So the vertex here is going to be -2, because that's opposite of the inside. Sorry, -1, same as the outside. So the vertex here is -2, -1. So this moves 2 units to the left. Remember, it's always opposite the inside. And 1 unit down. So 2 units to the left, 1 unit down. And then this is being multiplied by 2, which means the parabola is going to be narrow because it's growing twice as fast. So it's shooting up faster than it normally would. So this parabola is narrow. And since it's a positive 2, it's also face up. It's face up, narrow, and shifted. Okay, so before I move too far, actually let me save this page for the drawing. Before I move too far, let me now show you, for those of you who are like, you know what, that method doesn't really do it for me, I'd like a formula, let me help you with that. Or you'd like to just check yourself and have 2 methods, that's also cool. The more tools we have in our toolbox, you know, the more, the better we can choose and pick what's most appropriate. Okay, so this is the formula to find the vertex. Negative b over 2a comma f of negative b over 2a. All right, this is the formula, and this will give you the vertex. This will be h, this will be k when you plug all this in. All right, so the formula is set up so that a is the coefficient of the quadratic term, b is the coefficient of the linear term. So in this case, my a is 2 and my b is 8. All right, so let's do it. So there's a negative in the formula. We just said b is 8, 2a is 2. So the first thing you want to do is just crunch this part out here. So you've got -8 over 4. This is -2. Right, this is the only part of the formula where students tend to get a little confused, like what happens here. So what happens here is after you crunch out what h is, and remember h is a specific x, right? H is a specific x, because it's a vertex. Once you calculate what your x is, right? H is really just a specific value for x. K is just a specific value for y. Once you calculate what your h is, you take your h and you plug it back, which is x, you plug it back into the function. So this is the part where students get confused, so just make sure you catch this part. So now I take that -2 because I have the x value, now I just need to find the height of it. Alright, so -2 squared is 4. Alright, so after you crunch all that out, you'll notice you'll get -1. So the vertex is -2, -1. And if you notice, that is what we got by completing the square. So this first method, we would call this, we found the vertex by completing the square. Okay, where this second method is by using the formula to find the vertex. Okay, let's rock with this. I'm already at 10 minutes. You may find the rate of my voice speeds up. Oh, these movies. Okay. All right, so we said the vertex was -2, -1. So that would put the happy camper right there. All right, that's the vertex. I'm just helping you do this problem because I'm going to ask you one of these on the test. Now, the easiest way to find the y-intercept is actually off of the original form. It doesn't matter. You can get it off either. I mean, just do it the way you want to do it. At the end of the day, if you understand what you're doing, you're good. You're good to roll. I'm going to do it off of here. Y-intercept. I'm going to let x be 0 because that's how you find the y-intercept. I just write out the steps because sometimes people are very visual. They just need to see it. Okay, so the y-intercept is 7. You can sort of see it straight up, but that's the idea. Anytime you find a y-intercept, you're going to let your x's be 0. Now, let's do the point of symmetry. We talked about this the other day. This is 2 units away from the y-intercept, so it must have a buddy point that's 2 units away on the other side. So that would mean if I walked over to that position, I'd have to walk 4 units over and then 7 units up. I'd have to walk 4 units to the left and 7 units up to get to there. Now this one, and I mentioned this earlier, but it's good to always hear it a few times. This one has x-intercepts. It's going to cross here. And x-intercepts can, not all parabolas have x-intercepts. Some parabolas have x-intercepts that are easy to find, and some parabolas have x-intercepts that are not easy to find. Okay? So, here we go. X-intercept, you're going to let the y equal to 0. You can start it here or start it here. I'm not telling you how to solve it. I actually think it's good if you do it your own way. You're just solving a quadratic. So my brain likes to start here. This doesn't have to be your brain. This is called the square root method because I have something squared on a constant. So I'm going to move the 1 to the other side. So when you solve by the square root method, you first want to isolate the squared binomial here. I'm going to divide off the 2. Now I'm going to take the square root, and when I take the square root, I have to make sure that I plus or minus. Woo, 13 minutes if it cuts me off. I hope it doesn't. This thing loves to cut me off. Square root of 1 is 1. Square root of 2, I'll just leave as square root of 2. I'm going to move the 2 over. Alright, now if you notice, and you could have also done this by the quadratic formula, okay? That's another way to do it. I just like this one better. I just think it's quicker. But it really doesn't matter. It's really what your brain resonates with. Now, I'm going to put this in my calculator. I'll start with the, you know what, let me just do this fraction part first. So if you're doing it like me, you're doing 1 divided by the square root. Your square root key, it depends. Mine's like right above the x squared, so I have to hit shift x squared. By the way, if you don't have a calculator, you want to get one. My personal preference is this one, but I think it's easy to use is why, but whatever works for you is good. You are actually going to need a calculator that has sine, cosine, tangent, and also your transcendental functions, which are your ln and log. Okay, we're actually getting there quickly, so might be a good thing to order today if you don't have one. This is called a scientific calculator. Okay, as long as it's a scientific calculator, it has your trigs, it has your logs, you're good to rock. Your computer also has under, I think it's called Desmos. Also, on your computer, you can just pull it up. You don't even have to buy one. Alright, I'm sorry if I lost your train of thought here. Let me get us back on the tracks. I'm doing 1 divided by square root of 2. Yeah, actually, you don't even need to buy one. You could just go up on your computer or your phone, probably. Alright, so this is the same thing as saying x, not same, it's an approximation of saying plus or minus, let me just say, just because graphing, you can't get in real tight, let me just say like 0.7, okay? So one case you have -2 plus 0.7, the other case you have -2 minus 0.7. Okay, so plus 0.7 is -1.3, minus 0.7 is -2.7. Alright, so let's graph that. So -1.3, this is a little over that guy. Alright, so that's -1.3 comma 0. That's my x-intercept. Is a really nice problem. Hint, hint. -2.7, that will be closer to this guy. -2.7 comma 0. Okay. Alright, just to make sure we're on the same page, we did the vertex, y-intercept, we did point by symmetry. We did x-intercept here, we did x-intercept there. Okay, this is a pre-calc level quadratic, drawing a quadratic. This is a really nice example. This one is right on the line of what I would ask. Right on it. Alright, if you're going to solve this by the quadratic formula, you can, for the x-intercepts, you can totally do that. You're going to get the same answer if you didn't like the way I solved it. Okay, so if you're going to use quadratic formula, it's -b plus or minus